Okay, guys, hi, can you hear me? Okay, great. Okay, so let's start. As I said, if you have questions, please write them in the chat and I will answer to everyone, okay? So that otherwise, if I hear your voices, no one can hear me, okay? So today we're gonna start solving the questions you received on your agenda in the mail, and then I will give you a summary of the necessary concepts you need for the exam, okay? So we start with the midterm sample version 2 part 1. Okay, so for the following statement, please indicate whether it is true, false, or uncertain and explain why. If the price elasticity of market demand for a product is -1, and if the income elasticity of market demand for this product is +2, then the combination of a decrease in market price of 3% and an increase in household income of 1.5% results in a not change the total spending on the product. So what are the information here? Here we have that the price elasticity, so elasticity of quantity to price is equal to -1, and the income elasticity is 2. So the elasticity of quantity to income, M is income, is equal to +2. And then we have a decrease in market price, so price decreases by 3%, and an increase in income by 1.5%. The statement says that this means that the total spending do not change. So is this true, false, or uncertain? So this is the question we have to answer. So let's see how we can use the information to answer the question. First of all, the elasticity of quantity to price is -1. What is the formula for elasticity? Elasticity is equal to the percentage change in quantity to a percentage change in price. The elasticity of income is equal to percentage change of quantity divided by percentage change, in income. And the total spending are equal to price times quantity, so that the percentage change in total spending is equal to the percentage change in price plus percentage change in quantity. Yes, bill 2, total spending is the same as total revenues. Okay, so this is equal to total revenues. Okay, so remember this formula is a fundamental, so you have to keep it in mind. Okay, so percentage change in total spendings or percentage change in total revenues is equal to percentage change in price plus percentage change in quantity. Okay, so this is important for the exam. So what we want to see is whether this percentage change in spendings is equal to 0 or not. So percentage change in price, we know by the information of the problem, is equal to -3%, right? Now we want to see what is the percentage change in quantity. So we know that the quantity is going to change for 2 reasons. It's going to change because the price has changed, and it's going to change because the income has changed, right? So percentage change in quantity is influenced by 2 things: change in price and change in income. And moreover, how does the quantity changes when the price and the income changes? We know it from elasticity, so percentage change in quantity will be equal to -1 percentage change in price, and also percentage change in quantity is equal to 2 times percentage change in income. And we know this from the elasticities. Okay? So from the definition of elasticity and the numbers we have for elasticity, we know that, so basically from this elasticity and from the definition of income and price elasticity, we know by how much the quantity changes when income and price change. Okay, so we have that the percentage change in quantity will be equal to, the part due to the price will be equal to -1 times -3, and this is equal to 3%, right? And moreover, the quantity changes also because the income is changing, so it's 2 times 1.5, and this is again 3%. So the total change in quantity is equal to 6%. So now we can answer the question, because we had our total spendings equal to percentage change in price -3 plus 6, that is the percentage change in quantity, and this is equal to 3%. So the answer is false, because the total spendings are going to change by 3%. Yeah, Elizabeth, sorry. Do you want me to repeat? Okay, so again, to solve this question, the important thing, okay, so basically, again, the change in price is given by the problem. Okay, so the problem says that the price is going to decrease by 3%. So the information about the price change is already given in the question. What is not given is the percentage change in quantity. How did we find the percentage change in quantity? By adding up the percentage change in quantity due to the change in price with the change in quantity due to the change in income. Okay? So to sum up, for this problem and in general, when you have to look at the percentage change in total revenues or total spending, what you need to know is that the percentage change in total revenue is equal to percentage change in quantity plus percentage change in price. And you need to use the elasticity concept. Okay, so these are the important things for this kind of problem. Okay, so Lillian, if you have a question like this, the only way in which you can answer is using this equation of the percentage change in total revenue. But for example, you can put it in your sheet and so you have it. Okay, and then you just substitute the numbers. Any other question? Okay, so in this case, Serena is asking, yeah, if we consider normal. Okay, so basically, Serena, I'm gonna answer your question at the end when I give you the summary, okay, for the exam. I will show you how elasticity and normal and inferior good are related. Svetlana, yes, total revenues and total spendings are the same for all the course, okay? So in our course, total revenues and total spendings are always the same. Other questions? Okay, so whenever the elasticity of demand to income is greater than 0, you have normal good. So since here is 1.5, this is a normal good. So if the elasticity of quantity to income is greater than 0, you have a normal good. If the elasticity to income is smaller than 0, you have an inferior good. Okay, so in this case, since the elasticity to income is 1.5 positive, you have a normal good. Okay? But I'll go back on this at the end of the session when I give you the summary for the exam. Now in this case, okay, so Svetlana, in this case, you don't have to take the absolute value, because if you take the absolute value, you will always have a positive elasticity, right? So you take the elasticity in absolute value only when you consider elasticity to own price, okay? So elasticity of quantity to price, you consider only the absolute value. When you consider cross price elasticity and elasticity to income, you don't use the absolute value, okay? So you just need elasticity to be greater or smaller than 0. Why is this the case? Because if the elasticity is positive, this means that when you increase the income, you increase the quantity demanded. If the elasticity is smaller than 0, it means that when you increase the income, you decrease the quantity demanded, okay? Other questions? Okay, so if you don't have other questions, we move to the midterm sample version 2, part 3. Yeah, part 2 is not in the agenda. Okay? Okay, so a monopoly exists and it produces only one product and sells it within a regional geographic market. Initially, the monopoly sells its product at one price to all buyers because it cannot identify which buyers are willing to pay which prices. The initial demand curve D1 for the monopoly's product is a downward sloping straight line as shown on the accompanying page. Also, as shown, the monopoly's average cost curve and the marginal cost curve are a flat straight line. So our initial graph is something like this. So you have quantity and price, we have a demand curve D1, and a straight line that is our average and marginal cost. Okay? Now, some new families move into the geographic area, resulting in an outward shift in the market demand for the monopoly's product. So the demand shifts to the right. The new demand curve D2 is parallel to the initial demand curve as shown on the graph. So our new demand curve D2 is something like this. Okay? So we have increased the demand. Part A says, using the graph, show graphically and explain both the initial profit maximizing price, that is before the increase in demand, and the new profit maximizing price after the increase in demand. Assume that the monopoly uses one price to all buyers in each situation, but that the price might be different from one situation to the other. Okay, so here we have to find graphically the profit maximizing price for the two situations. So we start from D1 and then we do the same for D2. As you have seen in class, what is the optimality condition? The optimality condition is marginal cost equal to marginal revenue. Right? Now we already have in the graph the marginal cost, that is this straight line. We need to draw the marginal revenue curve. The marginal revenue curve is a curve that is a straight line halfway between the y-axis and the demand curve. So I'm going to draw it for demand curve 1. So it's halfway between the demand curve D1 and the y-axis, and this is my marginal revenue 1. So that what is the optimality point is here where marginal revenue is equal to marginal cost, so that going back on the demand function and going back on the y-axis, I have my optimal price when the demand function is D1. And going back on the x-axis, I also have the optimal quantity Q1. Okay? So this is for the initial situation when we have only D1. So again, we need to find a point where marginal revenue is equal to marginal cost. How do we find the marginal revenue curve? The marginal revenue curve is a curve starting from the intercept of the demand function D1 and going down halfway between the y-axis and the demand curve. So MR is halfway between the y-axis and the demand curve. Okay? Any question on this? Okay, so we do the same for the new situation, that is when the demand curve is the D2. Okay, so we are on sample. Yeah, thanks. Okay, so we do the same for demand curve D2. Now we already have the marginal cost curve. We need to draw the marginal revenue curve when the demand is D2. So again, we start from the intercept of the demand curve and we draw a straight line halfway between demand curve D2 and the y-axis, and this is our marginal revenue curve 2. Then we need to find the point where the marginal cost and the marginal revenue curve cross. And this point is here. So that going back on the demand curve 2, we find the optimal price P2 and the optimal quantity Q2. Okay? Questions? Okay, so you can name the curves as you wish. The important thing is that you understand and you are consistent in your description of the situation, okay? Then you can number them as you wish. Other questions? Right, Bill? So here we don't have any numbers, so you don't have to come up with numbers. You will only come up with the P1 and P2, where you can show that P2 is greater than P1. Okay? So Elizabeth, you don't need to write an explanation as long as you give me this graph. Okay, so if you give me this graph, for me is enough. Jay, I cannot infer anything about the elasticity here because I don't have any numbers, so I don't know what is the slope of the demand curve, so I cannot really say anything about the elasticity. Other questions? Okay, so something, yeah, Varun? Yeah, exactly. So don't worry about explain. I mean, if you always have to explain, but the graph is enough. Okay, if you graph me this and you write me that the marginal revenue must be equal to the marginal cost, you are totally fine. Okay, so an advice is that you have to answer, but you don't have to give me a long answer like in the problem set and in the samples, he writes. Okay, so you just need to give me a short answer with an explanation that makes sense. If the explanation is short but makes sense, for me it's fine. Okay? And also, I suggest you to use more the graphs than the words. Okay? Other questions? Yes, Svetlana, this is very important. For monopoly, it's always marginal revenue equal to marginal cost. And yes, it is also for perfect competition actually, but in perfect competition, marginal revenue is equal to price. So in perfect competition, you have price equal marginal cost. Okay? Okay, so Elizabeth, it could be, it could ask you other types of price discrimination, like for example in part C here we have two prices to different groups, right? So it is not always the case that you have one price to all buyers. Again, Varun, in perfect competition, marginal revenue is equal to the price. Okay? But we will arrive at that later on when we have a question on perfect competition, okay? But remember that their price is equal to marginal revenue. Other questions? Okay, so part B says show graphically and explain the sizes of the total economic profit for a monopoly for both the situation with the initial demand curve and the situation with the new demand curve. Does the economic profit increase, decrease, or stay the same? So basically what we found in part A, So in part A, we found that under demand curve D2, price is greater than P1 and quantity sold is greater than quantity sold when the demand is demand curve 1, okay? So then now, how do we find the profits? Profits, remember, that are equal to price minus average cost times the quantity, okay? So let's go back on the graph and let's see what are the profits under demand 1 and 2. So basically, profits under demand curve 1 are price, P1, minus average cost, that is this, times quantity Q1. So this area is the profits under demand curve 1. What are the profits for demand curve 2? They are equal to price minus average cost times quantity under demand curve 2, so this bigger triangle. So as you can see, the orange rectangle is greater than the yellow one, and so the profits are greater under demand curve 2. Okay? So by the way, at the end of the session, I will send you this document, so you don't have to care about this, okay? Yes. Tonight I will send you this document, and tomorrow I will upload the video, okay? So any question on how to find on the graph the profits? Okay, so the answer to part B is that the economic profits are increasing. Why are they increasing? Because both price and quantity are increasing, and this means that the profits are also increasing. Okay? Questions? Okay, so part C says that it might be, yes, Lillian, you don't have to do the math here also because you don't have any number. You can show it on the graph, okay? And yes, since both price and quantity are increasing, that for sure the profits are also increasing. Okay, I'll leave you a minute for other questions. Okay, so Michael, here both the price and quantity are increasing. Every time the demand increases, also the price and quantity will increase, right? Because there is much more pressure from the demand because it's increasing, and this makes both the quantity sold and the price increasing, okay? So yes, demand increases, then you have both price and quantity increasing. Okay, so part C, it might be possible for the monopoly to keep the two groups of buyers separate. The two groups are one, those included in the initial demand curve, so the first group is D1, and two, the new families that cause the outward shift in the demand curve. Why would the monopoly want to keep these two groups separate? Explain. And if the monopoly could keep these two groups separate, what price would the monopoly charge to the group included in the initial demand curve? And what price would the monopoly charge to the group of the new potential buyers? Explain. So first of all, why would, in general, the monopolist want to keep the two groups separate? Because as we have seen in class, when you can do some kind of price discrimination, you always increase your profits. Okay, so the fact that you can charge different prices to different groups will make the profits to increase. So what price would the monopoly charge to the two groups? So here we have that the first group is again demand curve 1. So on the graph we have D1 and the new curve D2. So let's regraph the two demand function. So we have our initial D1, and this was our initial D2, and our marginal cost average cost curve. Okay, so basically now one group is D1. How do we separate the two groups on the graph? As you have seen in class, when you have a demand function and you want to separate it into groups, basically one group will be the demand curve above the point where the second group starts. Okay, so here D1 is one group, so that the other demand curve, we will call it D3, is this part of the new demand function. Okay, so we are just separating the two demands, so that we are going to have two new graphs, one with the original D1 and one with the new D3, where D3 starts at the intercept of D1, okay? Sorry, ends at the intercept of D1. So basically here, this point where D3 starts is the same as this point. I'll call it point A. And this point B is equal to this point B and this point B. Okay? Questions on this? So in general, remember that when you have to separate a demand function, and let's say that the problem says you want to separate all the people that want to pay a price greater than $6 from the people who want to buy at a price lower than $6. Yes, Bill too. So whenever you want to separate the two demand functions in two, you will have that the first demand starts from the intercept until this price at which you want to separate the demand, and the other demand starts at the price at which you want to separate the demand. So again, to give you an example, let's say that you have you have a demand function and you want to separate all the people that want to pay a price higher than 6 from the people who want to buy a price lower than 6. Your new two demands are one is this one, and the other one is this one. Okay? And then you just use two different graphs and do the standard analysis. So you will have D1 until the price of 6, and then you have D2 starting at the price of 6. Okay? So this is how you generally separate the demands. Questions? Okay, so now that we have separated our demands, how we do the analysis for the okay, so so first of all, what is the reason for separating the two groups? Is that when you can discriminate, that is when you can give different price to different people, you increase your profits. Okay, so the more you can separate people and give them different prices, the more consumer surplus you can gain, and so you can have higher profits. Okay. So again, in the example, what happens here? That starting at, okay, so let's go back to the example because I want you to have this clear. So basically, when you say that you want to keep separate all the people that want to pay a price higher than 6 from the people who want to buy at a price lower than 6, what happens to the people? Okay, so let's take D2. How many units they want to buy at the price of 6? 0, right? How many units do they want to buy at the price of, let's say, 5.99? 1, right? This is the reason why I'm shifting to the left. Okay? Is it clear? Okay, so here, yes, Varun. So now what happens? That what is in my example, the quantity that maximize profits. For the one, I will now draw my marginal revenue. And then I need my marginal cost, and let's say that here the marginal cost is this. Okay, so what happens here? Oh, I drew it very badly. Now, if this point where the marginal revenue is equal so here, now, Elizabeth, this is an example, okay? Okay, guys, are you all with me? This is a general example just to show you how to separate in general the demands when you have a number for the price, okay? So what is the marginal revenue? Marginal revenue must be equal to the marginal cost. I go back on the demand function, and it happens to be that the quantity and the price is 6, and the optimal quantity is this Q star, okay? For D2, I do the same, marginal revenue equal to marginal cost, and this will be my price, and this will be my quantity, okay? So again, as usual, I use the same marginal revenue equal to marginal cost optimality condition. Okay? Any question on the example? Okay, so let's go back to our problem. So we are back here where we separated the two demands. Okay, so now we have D1 and D3. Now we want to see what is the optimal price, that the two optimal prices that the monopolist will set on the two different markets. So again, we need the marginal revenue equal to marginal cost, so that we draw our marginal revenue curve here and here. And then we have that the marginal cost was somewhere here. Okay? So we need the points where the marginal revenue is equal to the marginal cost. So for D1, this is the point. So that P, the optimal P is P1 star. And this is the same as the initial demand function, right? Because this is exactly the same analysis we did for the initial demand function. So this is equal. Okay. Now, more interesting is the case for D3. Now, the marginal revenue is equal to the marginal cost at a point that is well beyond the maximal number of units D3 wants to buy. Okay, so this is the maximal quantity that D3 will buy. So that what happens, since at this Q bar, the marginal revenue is greater than the marginal cost, because marginal revenue is here and marginal cost is here. So this is the difference between marginal revenue and marginal cost. You want to sell all these units so that for D3 the price will be exactly B. So the optimal P3 is equal to B. Again, why is this the case? Because at the maximum number of units that D3 will buy, the marginal revenue is still greater than the marginal cost. So you want to sell all the units that these guys want, and the price will be the price B. Okay, the price corresponding to this Q bar. Is it clear? So in general, every time you have demand function, yeah, sure. So again, whenever you have a demand function that is in some sense that does not continue until the x-axis like D3, if at this point the marginal revenue is greater than the marginal cost, and here is the case, you want to sell all the units. Okay, so I'll graph you D3 bigger so that you can see what I mean. So my D3 finish at B, at the point B, while my marginal cost is here. So that what is my marginal revenue curve is this one, okay? Now what happens that whenever my optimality condition is marginal revenue equal to marginal cost, okay? But at this point, what happens is that the quantity that you would want to sell is higher than the maximum quantity that D3 is going to buy, right? Because corresponding to the point B, there is the maximum quantity that D3 is going to buy. That is, any unit after Q bar is going to be sold to segment D1, okay? And this is better for the firm to sell all the units after Q bar to D1, okay? Because D3 are ready to buy at a higher price. So why should I sell them to a lower price? So you want to keep them separate. So again, since at Q bar marginal revenue is greater than marginal cost, because this is the marginal cost at Q bar, this is the marginal revenue at Q bar. Since marginal revenue at Q bar is higher than marginal cost at Q bar, I want to sell all these units. If Okay, so if instead, remember that the optimality condition is marginal revenue equal to marginal cost. So if marginal cost instead was greater than marginal revenue, you wanted to sell less units, right? So you wanted to decrease the number of units sold until marginal cost equal to marginal revenue. Okay? Is it clear now? So now I will add on this graph. Okay, so let's add on this graph our demand curve D1. Basically, D1 would start at B and go down all the way down, right? So that my marginal revenue is, my marginal revenue curve is this one. This was D1. So that what is the optimality condition for D1? I go back on the demand function and I have P star and Q star. Okay? So that at the segment D1 you want to sell at the price P star, P1 star, and at the segment B, at the segment D3 you want to sell at the price B. Okay? So basically, what is the total amount, the total number of units you are going to sell? So total Q you sell is Q bar plus Q star. Okay? And the prices are P star 1 to D1 and B to D3. And this, by definition, assures you that you will have the highest possible profits, okay? So segmenting the demand function will give you a higher profit than not segmenting it, okay? So you always want to do it. By definition, okay? So for example, okay, so Svetlana, Q bar, so Q bar, okay, Q star is the optimal number of units that you will sell to segment D1. So my Q star is what in my first graph. Okay, sorry. Okay, so basically Q star is the optimal quantity sold to group D1. Okay, so this is Q star is found by making MR1 crossing with the marginal cost. Okay, so here I found Q star, and the Q bar is the optimal quantity sold to the group D3. Okay, so this is my Q bar. Okay, Svetlana, yes, Q1 and Q3, okay? And for Lilian, what is an example in the real life of this kind of price segmentation? For example, can be when you sell different airline tickets to different groups, right? So let's say that you sell to students and businessmen different types of different prices. Or you can think at old people and young people when they have discounts at museums. Okay, so these are real world examples of price discrimination, price segmentation. Okay. Okay, so again, what you have to bring at home from this exercise is that when you need to segment the demand, you separate the demand in two. You shift to the left the demand that the part of the demand that is lower, and then you do the usual analysis: marginal revenue equal to marginal cost. Okay, If the marginal revenue is greater than marginal cost, you want to sell all the possible units to that group of buyers. Okay? So I write down the procedure. So for segmentation, one, separate the two demands. And two, use marginal revenue equal to marginal cost to find optimal prices and quantities. If for one group marginal revenue is greater than marginal cost, sell all the possible units that you can to the group. Okay? Questions? Okay, so if you don't have any other question on this, we go to problem set 3, question 6. Okay, so your profit maximizing company has a monopoly on the provision of a specific type of financial advice offered to a set of 10,000 households. Each household has the same downward sloping straight line demand curve for the service per year, with the units of service measured in hours of advising as shown in the graph below. Okay, so here in the graph we have number of hours on the x-axis and price per hour on the y-axis. The lowest price per hour at which no one would buy any of the service is 200 per hour. So if this is our demand curve, we know that the intercept is equal to 200. Okay, so this is the information given by the problem. And the marginal cost of providing the service is a constant value of $50 per hour. So that the marginal cost curve is a flat curve equal to 50. Okay? Your monopoly charter has a limitation on pricing. You may choose one of these two pricing schemes for the year. First, you could charge only an upfront flat fee per year and allow a household that pays the flat fee to use as many hours of service as it wants to during that year. Okay, so the first pricing scheme, A, could be a flat fee per year and the price per hour is equal to 0. The pricing scheme B is charge only a price per hour of service to all households and charge no flat fee per year. So B is no flat fee and price per hour only. Okay? Part A says, which of these two pricing schemes is better for the company? Explain, using one or more graphs as appropriate. So basically, how do we conduce this analysis? We want to compare the profits for the firm under the two different pricing schemes. Okay, so one, compare profits under pricing scheme A with profits under the pricing scheme B. Okay? So pricing scheme A says flat fee per year and 0 price per hour. Okay? So that let's use, so let's analyze A. So basically, if this is our graph, if the price, and here remember that this is the price per hour on the y-axis and on the x-axis is the hours. So how many hours will the consumers, buyers will use if the price per hour is 0? That is what happens under pricing scheme A. So if price per hour is equal to 0, then how many units will the buyers use? We can see it from the demand function, and basically it's this point, right? Because this is the point where the price per hour is 0. Exactly. So if price per hour is equal to 0, let's call this point Q bar. That is the maximum number of units the demand want to consume. Then you will have that Q bar is the number of units they want to buy, they want to use, right? So what is the consumer surplus? The consumer surplus then is, remember the definition of consumer surplus is equal to the area above the price and below the demand, right? So the consumer surplus would be this triangle, okay? So now what is the flat fee, the optimal flat fee that gives the maximum profit to the firm? Is a flat fee per year that is equal to the consumer surplus. Okay, so if the firm wants to maximize the profits, he has to set a flat fee that is equal to the consumer surplus. Okay, this is by definition of of the flat fee. Okay, so this is pretty standard. Every time you just want to set a flat fee, the flat fee will be equal to the consumer surplus. Okay. Now, what is if the flat fee is equal to the consumer surplus? Now, what are the profits for the firm? For now, what we have is that the total revenues for the firm are equal to the consumer surplus, right? So that TR is equal to the consumer surplus. What are the total costs? Total costs are equal to the average cost times the quantity. So total cost will be equal to 50 times Q bar, right? So that the profits under plan A are equal to consumer surplus minus 50 times Q bar. Okay, so that basically, let's see what happens on the graph. So basically total costs are 50 times Q bar. So these are my total costs. my total revenues were the green area equal to the consumer surplus. So what are the profits? The profits are total revenues minus total cost, so that the total revenues, the profits will be equal to this area minus this area, right? So that the total profits will be something smaller than this blue triangle, okay? So basically this blue triangle minus, let's say, minus this, okay? So this will be my total profits. Okay? Okay, so Elizabeth, this is something that, I mean, it's not intuitive and I agree with you, but the fact is that in general, total cost is equal to average cost times quantity, right? So basically it is a rectangle because you are not, we are producing Q bar, okay? And at Q bar the cost is this one, right? So basically the costs are all this big area. Sorry with the colors. Okay, so the total cost, remember that is equal to average cost, and the average cost is 50 times Q bar, and Q bar is until here, right? So all this rectangle is the total cost. Yes, Lillian, basically what happens here is that with only the flat fee, you are selling more units that you want. Basically, the optimality would be to sell until this number of units, okay? So until here, okay? But the fact is that since you are selling at a price per hour of 0, consumers will also consume these extra units. You don't want that, but with only a flat fee per year, you have to sell them everything, okay? This is the reason why the total costs are so big and are also above the demand function, okay? Any other question? Okay, so again, remember that so under this price scheme, the profits are the blue area, okay? So these are my profits. Now let's compare these profits with the pricing scheme B, that is charge only a price per hour without a flat fee. And let's see what happens. So again, we have our graph where we have our demand function and the marginal cost. Price per hour on the y-axis and hours on the x-axis. So now here we have the marginal cost, and the optimality condition says that marginal revenue must be equal to marginal cost. So under this price scheme, we want to find the point where marginal revenue and marginal cost cross, and we want to find in that way the optimal quantity and price. So the marginal revenue is halfway between the y-axis and the demand curve. The point where they cross is this one, and so we have the optimal price and quantity. Okay? So in this case, what are the profits? Here it's easier to find the profits because the economic profits are, as equal to price minus average cost time quantity. So basically my profits now are this area, okay? So let's compare the profits under scheme A and B. Basically, as you can see here, the profits are lower than before, right? Because before we had under price scheme A, if you remember, the profits were equal to all these triangle, let's say, until here. So profits under price scheme A are greater than profits under price scheme B, okay? Questions? So this means that the flat, sorry guys. So this means that the flat fee is better here. Questions? Okay, so this is not a general rule, but it depends on the marginal cost. Okay, so whenever the marginal cost curve is low enough, that is the marginal costs are low enough, then it's better a flat fee. Why? Because you remember that when we had the flat fee, you didn't want to sell these extra units, but you had to because the price was zero, right? So selling those extra units were not good for your profits, but was better than only selling the per hours, only selling per hour. But if the marginal cost is too high, then producing those extra units is too costly and it's not worth it. So basically, if the marginal cost is low enough, then a flat fee is better. Okay, basically because it doesn't cost you that much to produce a lot of units. If MC is high enough, then you prefer the per hour because now it's too expensive to produce and sell too many units. Okay? What is low enough and high enough depends on the problem, obviously. No, it depends on the problem. So it depends on the slope of the demand curve and whatever. But you can just use low and high enough depending on the variables. Okay. Other questions? Okay, so Elizabeth, I will do the analysis on two different graphs, and then I will do another graph with the two profits, one on the other. Okay? So here we don't talk about fixed cost because fixed costs have already been paid in the short run. So in the short run decisions, you don't care about the fixed cost because they are sunk cost. Okay? Okay, if you don't have other questions, I go on part B. That says, if the company can gain the right to charge both an upfront flat fee and the price per hour of service, what should the company do, and explain. So now we are mixing the two pricing schemes. So pricing schemes A and B, that is you can both have a flat fee and then a price per hour. So let's see what's gonna happen. So again, we have our graph. Okay, now what happens that, okay, this is something you're going to learn, and then it's always the same when you want to use a flat fee and a per hour pricing. So basically how to maximize the profits. So you want to set the price equal to the marginal cost. So that basically you are going to cover the marginal cost, so the cost, sorry, you are going to cover the cost, because remember that this is equal to average cost, with the price, okay? And then the flat fee, so that this leaves the consumer surplus, so this will be your price, so that the consumer surplus will be this triangle, and this will also be equal to the flat fee, so that you can maximize the profits. Okay, so this will be your pricing scheme. So price equal to marginal cost and flat fee equal to consumer surplus. In this case, let's see what are going to be the profits. Profits are equal to, remember, so flat fee plus price time quantity, where the quantity is this Q, let's call it Q2. So plus Q2 times price minus the cost, that is equal to Q2 times AC, right? So that basically these two terms are the same, so they are going to disappear, so that the profits will be equal to the flat fee, that is equal to the consumer surplus. So this area is your profits now. So that, as you can see here, you have the highest profits. So with this pricing scheme, you have higher profits than before. So the profits from, let's call this pricing scheme C, are higher than the profits in A and also of B. So pricing, so when you can both choose a flat fee and price per hour, will give you the highest profits ever and always. So this is a rule. Okay, so Svetlana, what happens here is that to maximize the profits, when you can have a two prices, that is a flat fee plus the price per hour, by the theory, you have that to maximize the profits, you set the price equal to the marginal cost, and then the flat fee equal to the consumer surplus. Okay, so you don't need to look at the marginal revenue. Basically, here, as I said before, the price here can be seen as a marginal revenue, okay? So if you want, again, to see where the marginal revenue is equal to the marginal cost, then you can set price equal to marginal revenue, and so Q2 will be where the marginal revenue and marginal cost crosses, but this is a mess. So it's better if you think just that to maximize the profits, you have to set a price equal to marginal cost, so that from that you will find Q2, and from the consumer surplus, then you will find the flat fee, okay? So as I was saying, when you can both have a flat fee and the price per hour, for sure you are going to have higher profits than in the previous cases. Okay, and this is always the case. Questions? So an example is like Disney World, Disneyland. What is the park? Those amusement parks where you pay an entrance fee and then you have to pay extra for going to some particular rides, right? So amusement parks are an example, or whatever, every kind of example where you have to first pay a fee and then you also pay for the extra units. Other questions? So example, amusement park. So again, this exercise is actually more a theory exercise because it explains you how to maximize the profits in these three different with these three different price schemes. Okay, so if you learn how to solve this problem, actually you are learning a piece of theory more than there are no other possible exercises with these price schemes. Okay. So again, whenever you want only a flat fee, you are going to set a price of 0 and the flat fee will be equal to the consumer surplus. When you want only a price per hour, you do the usual analysis, marginal cost equal to marginal revenue. And when you want to mix the two pricing schemes, then you take price equal to marginal cost and the consumer surplus equal to the flat fee. Okay? Questions? Okay, so if you don't have questions, we go to version 1 midterm exam part 1B. Yes, Brandon, go. Okay. No, Brandon, remember that the flat fee, okay, so the total profits are equal to the consumer surplus, and this is already, this is a flat fee, so it's not times quantity, okay? It's already all the triangle, okay? So here the flat fee is equal to the consumer surplus, so it's already equal to basically is equal to 200 minus 50 times Q2 divided by 2. Okay, so this is the same as 200 minus 50 times Q divided by 2. Okay, so if you want to see the quantity, you see that I already computed it in the consumer surplus. Okay, exactly. Svetlana. Okay, so okay, I'm gonna explain it again. So basically, what's gonna happen that okay, So why do we subtract that small triangle in part A? So this is my demand, this is my marginal cost equal to average cost, okay? So basically in part, as we have seen, in, let's say in part B, what happens is that since the quantity sold is this Q2, what is the total cost? Total cost is equal to average cost minus, average cost times quantity. Okay, so these are my total cost in part 2, okay? So basically, this is a minus, right? Because our cost. So it's a enters the profit with a minus. And the total revenues instead are this big area, right? And this is a plus. So what is the profits? The profits are plus minus, so total revenues minus total cost. So my profits are this triangle. Okay? Are you with me? Now, okay, now in part 1, instead we had the quantity sold was this one, right? So that what is the average cost? So the average, the total cost. The total cost is not only, I mean, you have to compute the total cost for all the units sold. So you have to add also this, right? Because these are cost. So my total cost in 1 is this big rectangle. And this is a minus in my profits. Okay? Now the total revenues in that case were instead all the triangle. So was this, right? Okay, so that the profits now are total revenues minus total cost, right? So that basically, let's see what areas are covered, what area of the total costs are covered by the total revenues. So basically this part on the graph, this part is covered by total revenues, right? So they go away. The total revenues here go away, right? But I still have this part of the total cost here that I didn't subtract, right? So I'm going to subtract them here. So this goes away, and I'm left with this thing. Okay, so it's only a graphical matter. Okay, can you see it now? Okay, I mean, I understand that graphically this is not intuitive, so it's enough that if you don't like to draw it this way, you just say what are the total revenues and the total cost. Okay, and that's it. You can stop there. Okay. You can say that. Okay, so the other way in which you can say it is that total revenues are equal to, remember that this is a 200 and this is Q bar. So 200 times Q bar divided by 2, and this is the area of the big triangle. And total cost is equal to, remember that this is a 50, so it's 50 times Q bar. So that the profits are equal to total revenues minus total cost. Okay? So this is the algebraical way of saying it. Okay? Other questions? Okay, so midterm exam version 1, part 1B. Consider a perfectly competitive market for a normal good. A specified increase in consumer money incomes results in a larger change in the market price of the good If the price elasticity of supply of the good is 1.5, then if the price elasticity of supply of the good is 2. Okay, so we have, the information is that we have a normal good. This means that as income increases, also quantity demanded increases, right? And second, we want to compare what happens to price when the elasticity of supply is 1.5 compared with when the elasticity of supply is equal to 2. Okay, so when the price increases the most. Okay, so basically the first information means that whenever if I have the demand curve like this, if I have an increase in income, this is what's gonna happen. So the elasticity of supply is the elasticity of the supply curve. Okay, so it's not the opposite, but as the same as you have the elasticity of demand, that is the quantity demanded decreases as the price increase. For elasticity of supply, you want to see by how much the quantity sold, the quantity offered increases when you increase the price. So the elasticity of supply will be always positive, right? Because the higher is the price, the more you want to offer. Okay? So this is what happens when income increases. So the information that we have is first that the income is increasing. Since we have a normal good, we know that when the income of the buyers increases, the demand will increase. Okay, no, Varun, this is a shift of the demand curve. Okay? Exactly, Biltu. So when you have an increase in the income, at every price you want to consume more units. So be careful on this. So basically the shift of the demand is when you have a change in income or a change in preferences. Okay? Instead, a movement along the demand is when the price changes. Okay? Okay, perfect. Okay, so thanks, Biltu. Okay, so here we have first that the income has increased, and this means that demand curve shifts to the right. And you want to see what is the impact of two different supply curves. One with an elasticity of 1.5 and one with elasticity of 2. So basically, let's draw these two supply curves. So we have a supply when the elasticity is 1.5 and supply when the elasticity is 2. So remember that the lower is the elasticity, the steeper is the supply curve. Okay? Okay, so these are our two possible supply curves. And now we have our initial demand curve and our new demand curve after the increase in income. Okay, so we want to compare the equilibrium prices. So basically the equilibrium price, if the supply curve is more elastic, is this one, and the equilibrium price with the less elastic supply curve is P1. So basically it is true that whenever you have a less elastic supply curve, the change in price is higher when you increase the income. So the statement is true, because P1 is greater than P2. Okay, so what is the idea for this? Basically, if you increase the income, this means that the quantity demanded is increasing. So as you increase the quantity demanded, the price increases. Okay, but what is the reaction of the supply curve to a price increase? The quantity sold increases. When you have a less elastic supply curve, this means that it will react less to the increase in price. So basically, they will sell less units than a more elastic supply curve. And this makes the price increase more. Remember that less elastic in this case is, so less elastic means that it's a smaller number, okay? So yes, Diego, exactly in the same way as for the demand curve, also for the supply curve, the elasticity changes along the line. So yes, Elizabeth, less elastic means higher change in price. So why? Okay, so how did I draw this elasticity, these supply curves? Basically, remember that the elasticity is strictly related to the slope of a line. Okay, remember that elasticity is equal to the derivative of the quantity with respect to price times price over quantity, right? Where here the quantity is the quantity supplied. So this is the slope, so that elasticity and slope are closely related. So a lower elasticity means a steeper curve, okay? Michael, I'm going to answer your question when I give you a summary for the final exam. Okay, did I answer all your questions? Yes, Diego, basically what is saying here is exactly this, yes. So again, why is this the case? Because I'm going to write it down. So basically, if the income increases, this means that quantity demanded increases, and this will make price to increase. A less elastic supply curve will react less to the increase in price. And this means that so they will increase less the quantity supplied, and this will make the price to increase even more. Okay? Questions? So is the logic behind clear? Okay, then if you don't have questions, we go to midterm sample version 2 part 4. That is our last question, so that then I can give you the summary of what you need to know for the exam that I really care about giving you. Okay? So, midterm sample version 2 part 4. So here there is a perfectly competitive market for barley, and this market is initially in the long run equilibrium. For this initial situation, the graph of the attached page shows the market demand curve D0 and the typical firm average cost curve AC0. Here are two other things that you know about the initial situation. So first, I'll graph the demand curve. So we have our demand curve D0 and our average cost 0 for the firm. Okay, so this is our initial information for the market and the firm. Okay, and here are two other things that you know about the initial situation. The minimum average cost that the typical firm can achieve is $40 per ton. So we know that at this point the minimum average cost is 40. And the minimum short-run average variable cost that the typical firm can achieve is $28 per ton. Okay, so that average variable cost, the minimum is 28. Okay, so these are our information. And part A says, show graphically and explain the initial long-run equilibrium for this market and for the typical firm. Focus on price, quantities, and profits. So as you know, in the long run, economic profits for the firm are equal to 0, and this means that the price is equal to the minimum average cost. Okay? Isha, yes. So that we know that the equilibrium price will be equal to 40, so that my supply and demand will cross exactly in a way such that the price is equal to 40. Okay? So that in the long run, the price is equal to 40. My quantity in equilibrium on the market is equal to Q star. And the typical firm will produce Q star, I will call it I, okay, for the typical firm. And profits are 0. Okay, so this is our long run equilibrium situation. Okay, so until here pretty standard, right? So again, since in the long run equilibrium we know that the profits must be equal to 0, we have that the price is equal to the minimum average cost. Okay, what is the supply curve here for the single firm? The supply curve we know is equal to the marginal cost above the minimum average cost. So this will be the supply for the single firm. Okay? because, sorry Svetlana, because the computer doesn't work very well, but it's a 40. Okay, thanks. Questions? Okay, so for now in part A, what they asked is what is the optimal price, what is the optimal quantity, and what is the profit in the long run equilibrium. Okay, so that we know that in the long run equilibrium the profits must be equal to 0, so that the price is equal to the minimum of the average cost. So we know that in the long run the price is equal to 40 and the profits are equal to 0. Okay, is it clear now, Elizabeth? So what it asks is just to describe the long run equilibrium price and quantities. It's not that, okay, Elizabeth, it's not that you want, is that if you, do you remember in class what Pugel said is that in the long run, to be considered in equilibrium in the long run, the condition that must be satisfied is that the profits are equal to 0. If the profits are not equal to 0, you are not in the equilibrium, because if they are greater than 0, new firms want to enter the market until the profits are equal to 0, right? Yes, Varun, this is 0 is for perfect competition. Okay, great, Elizabeth. And Sasha, yes, we can extend the fact that so 40 for the firm applies to the entire market. Yes, because we have a representative firm, so that we just sum all the firms that are equal, and we will have the same price for all the firms on the market. Okay. Okay. So again, here, since we are in equilibrium of the long run, we have a price equal to 40 and 0 economic profits. Part B says a change now occurs and the new short-run equilibrium includes the following. For the typical firm, the minimum short-run average cost now becomes 48 per ton, and the minimum occurs at the same output level. So basically here we have an increase in the variable cost. So that the average cost now becomes a line like this. No, sorry guys. So it's exactly the same as before. So the minimum, so it's just a shift, an upward shift. Okay, and the average variable cost now has increased to okay, so this is my new situation where I know that the minimum average cost here is 48, sorry. And the minimum average variable cost now is 36. Okay, so basically what happened here is that the variable costs are increasing. And finally, the problem says that due to this increase in the variable cost, the price now changes to $44 per ton. Okay, so that's basically what happens. Here the variable cost has increased. Since the variable cost has increased, the firm now wants to sell less units, so that on the market the supply curve will shift to the left, and the new price is 44. Okay, So again, why do we have this increase in price? Because the variable cost has increased. So variable cost increased, Q supplied decreases, and the market price increases. Yes, Varun, this is what happens in the short run. Okay? So basically, we were in a long run situation, and then there is this shock that makes the variable cost increases. So in the short run, now we have a price of 44 and less quantity sold. Okay? So the question says, what is the reasonable set of changes that would cause a shift to a new short-run equilibrium? Is exactly what I said. So the reason is that the variable cost has increased. So Varun, we will see that since the costs are increasing, if the increasing cost is permanent, you don't go back to the initial long-run equilibrium. If the increasing cost is temporary, then you go back to the previous equilibrium. Okay? So here we have to show graphically what is the new short-run equilibrium for the market and the typical firm. So, and should the typical firm stay open or shut down? Why? And show graphically the size of the economic profits. Okay, so after Q supply decreases, market prices, here is a market price increase, okay? So, I will expand the graph above to show what is the economic profits are going to be in the short run, okay? Again, remember that in perfect competition, you always have two graphs, one for the market and one for the single firm. Okay? So basically here you add your old average cost. So you add your old average cost that were here and the new average costs that are higher than before. Okay, and the supply curve starts from the average cost and is equal to the marginal cost curve, right? And this was equal to 40. This is your new average variable cost. So the information that you have is that the new average variable cost is in any case below the old average cost curve, right? Because the minimum is equal to 36. And this is important for the analysis. Now you'll see why. Okay, so this is the situation. So this is the new supply curve, S1. Remember that in the short run, the supply curves start at the minimum of the average variable cost, while in the long run, since average cost and average variable cost are the same, it starts at the average cost. Okay, so this was the old one. Okay, so basically here what we have that the supply curve now has shifted to the left, and the short run equilibrium is at 44. So let's go back at the firm level. with the new supply curve, this is the quantity that the firm wants to sell in the short run. Okay, so here I have AC0, that is average cost at time 0, and average variable cost at time 1, okay? I don't have any ABC0, that in any case would be the average variable cost at the beginning, before the increase in the variable cost, okay? Okay, Elizabeth? Okay, so now what do we have? This is the new short run situation. The short run equilibrium price is 44 and the quantity sold is Q star on the market and Q star I on the at the firm level. What is the economic profit? So first of all, the price is equal to 44, and as you can see, this is less than the average cost. So the average cost of this quantity is this one. So basically, this green rectangle is my loss, okay? Because price is lower, is smaller than average cost. Lilian, short run supply starts as average variable cost. Okay, so here the price is lower than the average cost because the minimum average cost now is 48 and the price is 44. Okay? But still, so this is my economic loss, so the profits are negative. But since price is equal to 44 and this is greater than the average variable cost, this means that the firm stays open in the short run. Exactly, Baron. Exactly, okay? So since the price is smaller than the average cost, we have an economic loss, but since the price is greater than the average variable cost, the firm stays open in the short run, okay? Questions? Okay, so part C says, given the new short-run equilibrium that you saw in your answer to question B, explain the process of adjustment to a new long-run equilibrium for this market. So now what happens in the long run? That, as I said, we know that in the short run, if the price is greater than the average variable cost, you continue to produce. But when you enter the long run, at that point, the fixed cost becomes variable, so that if the price must be now greater than your average total cost, and you can, if you are making a loss, now you can exit the market. So now when you can change the fixed cost is the moment where you could exit the market. So basically, since here the firms are making a loss, some of them will prefer to exit the market once they have recovered the fixed cost. Okay? So basically, since some firms will exit the market, there will be less units sold on the market, so that on the market the supplies are shifting to the left even more, until where? Basically, until this is the minimum average cost at 48, and it will shift to the left until the new equilibrium price will be equal to the new minimum average cost of 48. Okay, so again, in the long run, what happens is that since there are these economic losses, Some of the firms exit the market, the supply then shifts to the left, and this means that the price is increasing, so that the new price of equilibrium will be at 48, and the new quantity sold will be lower than before. Okay? So I will write it down. So part C, since profits negative, some firm exit the market in the long run. This means that the market supply shifts to the left until the equilibrium price is 48. This is long run equilibrium. Why this is the long run equilibrium? Because at the price of 48, the profits are at 0. Okay? Questions on this? So basically, in this kind of analysis, what you want when you are in the long run, what you want is to arrive at the condition, at the situation where the profits are 0. So you want to go back at the price where, at the point where the price is equal to the minimum of the average cost. So what happened in this problem? In this problem, we were already in a long run equilibrium where the profits were 0, and so the price was equal to the minimum average cost. But then there has been a shock, so that the variable cost increased, and so the new minimum average cost is higher than before. So the process of adjustment of the market is such that in the short run, some firms are making a loss, are suffering a loss, and then they will decide to go out of the market in the long run, so that there will be less firms in the market in the long run, and the profits will be back to 0 economic profits. Okay? Questions? Yes, Varun, this is only for perfect competition. Other questions? Okay, so if you don't have questions, I will write you down a summary of the things that are necessary for the exam, okay? So first of all, remember to write something on the answer sheet so that we can give you some points. Second, don't waste too much time in writing long answers, because what you want to do is to answer all the questions, so you don't have that much time. So be strategic, like be short and write things, okay? So the first thing that you need to know is elasticity. So own price elasticity. Cross price elasticity. And income elasticity. Okay? So that own price elasticity is equal to percentage change in quantity divided by percentage change in price. Cross price elasticity is percentage change in quantity of good X to a percentage change in price of good Y. And income elasticity is percentage change in quantity divided by percentage change in income. Okay? I don't know what's going on here. Okay? The second thing that, okay, so second thing that you need to know is if the own price elasticity is greater than 1 in absolute value, that is if the demand is elastic, then if you increase the price, total revenues decrease. If is lower than 0, if you increase the price, the total if you increase the price, total revenues also increase. Okay? The other thing that you need to know is the formula that I gave you at the beginning, that is percentage change in total revenues is equal to percentage change in price plus percentage change in quantity. Okay? Then for cross price elasticity, you have to know that if the cross price elasticity is greater than 0, it means that the goods are substitutes. If is smaller than 0, you have complements. And what we have said at the beginning, if income elasticity is positive, you have a normal good. And if it's negative, you have an inferior good. Basically, this is all what you need to know on elasticities. Then for monopoly, you need to know the optimality condition. Marginal revenue equal to marginal cost. And you need to know how to segment the demand. And you need to know the exercise we did before. You need to know how to set flat fee and per hour fees, per hour price. For perfect competition, you need to know that in the short run, if price is greater than AVC, you stay open. You need to know that in the long run, profits are equal to 0, and this means that price is equal to the minimum of the average cost. And you need to know that in perfect competition, price is equal to marginal cost. And then you need to know how to move from short run to long run equilibrium. So the second point, sure, long run, okay, so sorry, long run profits are equal to 0, and this means that price is equal to the minimum of the average cost. Okay? And then again, for last point, for perfect competition, you have to know how to move from short run to long run equilibrium, like the last exercise we did together. Okay? So these things are important and you absolutely need to know for the exam. Maybe there can be other things, I didn't see the exam, but for sure, if you know these things, you are gonna do well. Okay? Any question? Okay, so the answer, Diego, is no. Basically, another thing that I suggest you is to work on the problem sets and on the sample exams because they can be similar to the real one. I wouldn't waste my time on the BEI text, okay? Okay, so you will not be asked definitions. The exam is similar to the sample exam you have. You can be asked consumer surplus, yes, but not as a definition. You just need, for example, it can ask you to compute the consumer surplus for a particular problem, okay? But no definitions. Okay, guys, so if you don't have any other question, good luck for the exam, and if you have questions, you can send me an email, okay? Bye, guys.